everybody, my name is Weston Now. I'm going to be doing a presentation of my awning lowering design I made within Tinkercad for my MAE 4733 class. As you can see here, I have two Arduinos, two breadboards, a remote, motor, two IR sensors, LCD display, a power supply, and a couple of other things to get this all going. The project incorporated was initially for my parents. They wanted to install an awning in front of their front door to keep the sun from shining directly in through the window onto their TV when it got about 6 o'clock at night. They installed the awning and it works pretty good, but the problem is it's a pain for them to lower it and open it. My mom can't do it at all, and my dad struggles with it. So if we can motorize that system, it'd be a lot easier for them. Let's start by going through the code. If we look at, we'll start a look at Arduino 1. This is what I refer to as a slave Arduino, even though technically it's going to be sending some information to this other Arduino. This Arduino here will be doing most of the heavy lifting and actually controlling the motor. So I'll call this the slave Arduino. This Arduino's purpose is to control the LCD screen, take in a little bit of input from our remote over here, and also to send some serial monitor data over to the other Arduino. We start by including the libraries, and then we're going to define some variables. We have our switch. Our switch is actually this IR receiver here that I put into pin 10. These right here, this is just some syntax needed so that the IR remote library can start booting things up and start setting them up. The LCD display also has some of that. One more variable to define, and then we're ready to go. So within the void setup, you can see we've got our basic serial.begin at 9600, which is common for Arduinos. Pin mode being a switch and input. Remember, switch is 10, set that to input. LCD begin, so we can start it. 16 by 2, which is what our LCD's form factor is, and our enable IR. Within the void loop, we start by setting the LCD set cursor. We want to be able to print everything starting here and moving along. So now we're going to start by listening to what this IR has to say. So if when we decode the signal sent from the remote into our IR sensor, it's going to paste that into the results variable. So if the results.value equals a code, this code is sent by pressing each individual button, which has their unique code to it. So I used a simple if statement. If the results.value equals the code, in this case it's the left button, then the mode is going to be manual. That's going to be printed on the LCD display after clearing what, if anything, was previously on it, and then serial printing 1. I'm serial printing 1 or 0 in this case, so that it can be sent to the other Arduino, so it can know which mode to run the motor in. Both of these if statements are tied to what I call the left and the right buttons. Left being manual, right being automatic. So this final resume command keeps it to where when I push a button, it doesn't sit there in the serial monitor and load every single, or the one button that was pressed. It would sit there and repeat each time the loop happened. So I'm at 100 milliseconds, so it would repeat very, very quickly. Let's look real quick at what the second Arduino is doing. Second Arduino is a lot beefier. This is why I call it the master Arduino. So we go ahead and we start off with a handful of definitions to have. So we're going to include our remote library, we're going to define some pins and define some variables, start up just like the previous, and here we go. Under setup, pin mode 1 and 2 are outputs. That's all things for our H bridge here, which is going to help our motor change directions. Then we have an interrupt pin. I made this button a emergency stop button. No matter what the motor is doing, if I push that button, it should stop it. Serial.begin as normal, and then enable IR. Now it's going to go into the void loop. We're going to start by reading the serial data and defining a variable I call data as that. So data should only be either 1 or 0. And you'll see here we have a while loop for if data equals 0 and a while loop for if data equals 1. So if data equals 0, given by left or right on the buttons, you can see that we start off with our basic defining or listening to the IR remote, because I also put an infrared sensor right here. The nice thing about this is I can use one remote and two infrared sensors, and they all work together in tandem. It doesn't matter if this infrared sensor sees everything or this infrared sensor sees everything. We just tell it what's important. So I'm going to go ahead and define value. This is another way of reading which of these buttons works. This is a cleaner way of doing things because, as you can see, we can use a switch command and a case command and use only a 4-digit code instead of a much larger code for the other one. The light sensor, okay, sorry, got a little distracted for a second. So what we have next is this right here, and talking about what this is. So since we're in a while loop, all of the processing data is going to sit there and loop right here until data equals 0. So even if outside of the loop I say I want to go back into manual and make data equal 1, it's not going to see that because it's not defined as an interrupt. It won't interrupt this process to change data to become 1. So that's why I put this in here. So I'm going to go ahead and read the remote. So within our loop, if I push the remote button to the left to change it to manual, I will break this condition and it will kick us out of the while loop. But we're in auto right now, so let's see what that does. So right now, the auto mode reads a light sensor. The light sensor would be something I would put on the door perhaps, or besides the door, and it'll sense when, roughly 6 o'clock, hopefully if I have this tuned a little right, at about 6 o'clock, the right amount of sun should be on it, and it'll start it up. Next, what should happen is we have the actual turning of the motor. So when the light turns on, or the sensor sees that the light is on, we're going to start by turning on the motor. And we're going to turn it on in the simulation for only 1 second. But in real time, I have it set this turn on for a minute. Because after some math calculations, I determined that 1 minute of this motor rotating at, 100 RPMs after the 12 volts should completely lower my the awning that I'll be working with. So once it's lowered, and it'll lower all the way, it's going to stop. I have it stop for 2 seconds here for easy purposes, but it's going to initially stop in real time for 2 hours. That should give the sun enough time to set, and it'll be fine. Then it's going to close back up. Once it's closed, the awning doesn't need to be down all night long, so it'll close when the sun goes down. I just did that simply by setting a timer. After the awning closes, and it should take only a second or 60 seconds in real time to close, I set it to stop. So quick breakdown, awning opens, the awning stops, stays stopped for 2 hours, the awning closes, and the awning stays stopped, closed. Now let's look at while data equals 1, or our manual mode. Once again, we're reading the IR sensor. And this is going to be completely controlled by the infrared remote. So I defined some pins here, or defined some buttons here. This down button is going to lower it, or it's going to lower the awning. The play pause button I've set to stop the awning. Whether it's going up or going down, it'll stop it. Then the up is going to raise the awning back up. The 1 button here was a test for me, and you can see that's what the first case is here. I have it set here as test for remote functional. When I push that button, while I'm in the manual mode, we can start that up real quick. So I'm going to push left on the remote to kick us into manual mode. Unfortunately, right now Tinkercad has a bit of an issue where it's not running at 1 second, or maybe it's not an issue and it's just me not properly understanding what's going on with Tinkercad. But we're not rolling in real time. But mode equals manual, serial monitor says 1. That's parsed over to the second Arduino. So if I were to press 1 right now, according to my code, I should see a serial.print for that code. When I push 1, takes a second, but test remote is functional. Let's stop and keep going. So now, if I push button down, I've had it set to this low and high tells the motor that it needs to descend. On, I have defined to be 255, which is 100% of the speed. Button up, now is going to retract the motor. It's going to retract the awning back up. So we'll reverse it. Instead of low-high, it's now high-low at the same speed. The play-pause button, if you set them both to low, stops the motor. And then, since we're in a while loop, we needed something to break our while loop case. So if data equals 0, or if I press right on the remote, it should break our condition and kick us out of the while loop. Now that we're out of the while loop, we once again have this resume, which keeps the information from the remote from just filling up the system. Finally, we have our void click or my click function here. So this is my emergency stop that I've created. Once again, digital write, low, low to stop the motor. But since I made a function of it, you can see I put it back up here. It's part of our interrupt to stop the system, so that whenever I push my button, which I define to be right here, I do it, there's the name of the function, click, and when it's falling, so once I push it down, it should stop the motor. So that right there is a preview of the code. Let's see how well it actually works. So I went ahead and threw some annotations on. You can see we have the emergency stop button, power supply set to 12 volts. I have the motor is set to 118, you can see there, but it'll stay at 100 RPM when I put it at 12 volts. Then we have our controls. The left being the manual mode, right being the automatic mode, down being extend, up being retract, and play pause being a stop of the motor. I want to go ahead and point out that our photoresistor may be down here, but it's actually wired in to the first analog pin of the master Arduino. I put it down here so that when we're playing with the system, we don't have to go all the way up there just to change the lighting settings. So let's look at how this works and zoom in a little bit. When I start the simulation, you can see nothing's happening on our display yet. Let's go ahead and throw it in automatic mode and pretend that that's what we want to do. So since we're in auto, we should be able to turn the sun on, well, simulate the sun turning on. And you can see that almost right away, our motor kicks on. Now it'll be on for 1 second. Well, 1 second in simulated time. You can see how slow it's going. Once 1 second has passed, you can see it's about 0.6. Once we hit about 0.6, 1 second has passed, and it should turn off for 2 seconds. The reason I chose to turn off is because, well, the sun is supposedly going to go down in that time. So when the sun goes down, 2 seconds will have passed. I believe 0.6 is only the 1 second mark. It is. That's fine. 1 second will, 2 seconds will pass, simulating our 2 hours that we have set. And soon the motor will turn on in the reverse direction. It'll be negative and it'll pull it back up. So here we go, 0.5, 0.6. We're at negative 100 RPM. The motor's going back up. So I'm going to take this time as we're waiting to show how the interrupt works. So we are rolling at negative 100 RPM. If I go ahead and push our button, it stops it. And it's not at 0.6 yet, which shows that that's how it is. We'll go ahead and switch it back to auto after forcing it to manual to show that again real quick. See, we're in auto mode. Let's go ahead and say that the sun's up. Come on, Tinkercad, you can do it. There we go. Took a second, but we're at 100 RPM. But if I push this button, we're back down to 0. That's how the emergency stop works. It's an interrupt. So now let's go back to manual and see how that works. Remember, this is how we extend. This is how we retract. That's how we stop the motor. So if I push the extend button, it should do the exact same thing and just extend it. All we have to do is wait for Tinkercad to take its sweet time. Seems I might have a quick bug real quick. This wasn't happening before, but it would appear we're in manual. Oh, there we go. So it stopped like I told it to. Now let's see if we can extend it. There we go. Took a little bit of time. I'm going to blame that to Tinkercad's incredibly slow time processing right now that I'm having issues with. We're moving, press the stop button, and after the loop is finished, it should stop. Or we can extend. And as you can see, we're in manual mode. Let's see how our interrupt works. If we go up here and hit our emergency stop, click that and wait for a second, or I guess maybe click it a couple of times, it stops. So that's been a quick display of my project. Can't wait to actually build this in real life and get it all hooked up. There will be another video of that later to come. Thanks.